Okay? All right, what was the last thing I did? From these beautiful notes. Okay. All right. So, the last thing I talked about, it looks like, from Christina's notes, the last thing I talked about was finding the values, the trig values, for some of the special angles. So something like this. Let's just jump in and do one. Let's find the cosecant. There's your abbreviation of the cosecant. The cosecant of 5 pi over 6. We'll just incorporate a couple quiz questions in here. Cosecant 5 pi over 6. Well, we're probably not used to radians enough at this point to do the problem in radians. So you might want to go ahead and change that guy into degrees. And you can do that with a shortcut. You know pi is 180. A sixth of it is 30 times 5 is 150. So we can say the cosecant of 150 degrees. We could also always set up our proportion and do it this way. We're going to get the same answer because 6 goes into 180 30 times 5, 150 pi, so x equals 150. So you can always go through step by step by step if that's the way it works in your brain. All right, so we're going to do the cosecant of 150, so we're going to draw a picture of 150 degrees. And remember, in standard position, that would be this right here, 150. Now, how do I know that's 150? Because every quadrant is 90. Now, what do I do? I'm going to drop a perpendicular straight down, and I didn't let Maura ruin my day. She almost ruined my day. I almost had to sit down. She brought me a paper, and it turned out it didn't matter because she didn't do what she was doing. But she drew something, and it looked like this, and then she went like this.
I know.
Oh no. Never, ever, 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 ever would we ever draw a triangle like that. Okay? Alright. If we've got our triangle drawn appropriately, we remember that when we draw our triangles, and kids, you're going to do them in almost every problem. You're going to have a triangle, trigonometry, triangle measurement. You're doing triangles. When you draw your triangles, they're always part of the butterfly bow tie. So here we go. This is 150 degrees. It's not even in the triangle. That is not the important angle. This one is. What is the measure of that angle? He's the important one. 30. Now I can label the sides of my triangle because I memorized those. 1, √3, 2. And then I got to remember, this is the tricky part. Something might be negative. Is anything negative? The √3 is negative. Now, if you aren't in quadrant 1, something will be negative. Okay, let's just stop right there. If you are not in quadrant 1, something is going to be negative. Now, what's negative depends on which quadrant you're in. In quadrant 2, which is where we are, x is negative. These are negatives, aren't they? If you labeled these, wouldn't these be negatives? Now, what about these? If I counted up here, what about these? These would be positive. So the 1 is positive, the √3 is negative, and if I didn't tell you this before, write this down. The hypotenuse, or the radius, is always positive. Now, this is referred to as the hypotenuse or the radius because you can envision a big circle being drawn here, and that would be the radius of the circle. That number is always positive. No matter what, that number is positive. Okay, got it? Alright, so now we're all labeled, and I want the cosecant. Alright, I don't remember what the cosecant is because I never memorized it, and I have a math degree. So how do I do this? What do I have memorized? The cosecant is the reciprocal of the sine. And sine I know, Sohcahtoa. Sine is opposite over hypotenuse, so cosecant must be hypotenuse over opposite. So hypotenuse over opposite would be 2 over 1. So the answer to the question is 2. Now, does everybody remember doing some of those the last time we were together? If you have looked at your homework, you started doing the homework, you know that special angle worksheet is one of the assignments. It is page 2 in your packet. There are 10 problems just like this that you'll be doing as part of your homework. Okay? I've given you the answers on the back. So of course you could just copy them. That's not very productive, but I suppose you could. I put the answers there so you could check to see if you're on the right track or not. There is one little aspect of these problems, though, that we need to talk about. Because everything's been perfect so far. Let's do one more just to make sure we got this under control. And then I want to show you one little issue we might have. Let's do a cotangent of, how about 8 pi over 3. All right, now again, we've got a radian measure here. And after you've practiced enough of these, you could probably do the problem in radians, but right now we're probably still way more comfortable with degrees. So I just change that into degrees. So I got the cotangent of what? Pi is 180, divided by 3 is 60, times 8 is 480. Oh, 480. 480. That's
more than a circle.
That's more than a revolution. That's exactly right. So I'm going to go ahead and draw it because that's what I do. So there's 360, right? And now I need to go how much more? How much more?
120.
120. So I've gone 120 degrees more than a revolution. 360 is a revolution, so I go all the way around, and then I go 120 more. And in fact, is that extra 360 even important? No, so if it confuses you, just get rid of it and think of that as 120 degrees. Because that's essentially what you draw, right? Alright, now I'll drop my perpendicular straight down. This is the important angle right here, and how big is he? 60. There's nothing to memorize there. You use your noggin. It's 60. You know that to the x-axis is 180. If this is 120, then that's got to be 60, and this is 30. So I can label my sides. Anything negative, remember, if you're not in quadrant 2, or excuse me, if you're not in quadrant 1, something's going to be negative. What's negative? The 1. The 1. Cotangent. I don't have that one memorized either, but I know it's the reciprocal of the tangent. So the tangent is Sohcahtoa, opposite over adjacent. So this will be adjacent over opposite. Which adjacent over opposite would be what in this triangle? Remember, this is your angle right here, so it's all relative to that. So adjacent over opposite would be negative 1 over root 3. Or negative root 3 over. Now, done 2 of these, did a ton of them the other day. We good here? Because I'm going to show you the kind of little quirky thing. Okay. How about this one? what if I said to you, let's find the sine of pi over 2? Looks exactly the same as the other problems. We'll do it exactly the same way. We'll say, okay, pi is 180, so this is really the sine of 90. Right? Now, are you starting to, are you thinking about this now? Because what's your next step? You're going to draw, right? What's a little bit unusual when I draw this? 90. It's on an axis. Very good. This angle is what we call a quadrantal angle. A quadrantal angle is an angle that when you draw it, it's on an axis. Instead of sticking out in a quadrant somewhere making that butterfly thing, it's actually on an axis. What would be some other quadrantal angles? 90 is one. What are some others? 180, 270, 360, negative 90, negative 180, right? All those are quadrantal angles. So how do we deal with those? Because there's no triangle to draw. With all of our other ones, you know, with sticking out places, we've been able to create a triangle, label the sides, and do Sohcahtoa or something. That's not possible when you have your angle sticking straight up or straight out. If it's a quadrantal angle, we're not going to draw a triangle. What I'd like you to do is envision a circle here. And I'd like you to think about this point right here. Could you tell me the coordinates of that point? Could you tell me anything about the coordinates of that point? X is 0, for sure, X is going to be 0. And in fact, when we think about all of the quadrantal angles, will one of the coordinates always be 0, no matter which one of those we were on? Will one of those coordinates always be 0? Yeah. What about the other one? What does the other one depend on? The radius of the circle. And here is the great news. You can make the radius whatever you want it to be. You need a 90-degree angle, so you can have that radius being 100, you can have that radius being √7, you can have anything you want. Guess what I'm going to pick? Always, I'm going to pick 1, because 1 is like the simplest number in the whole wide world. And in fact, that circle is so special, it has a radius of 1, and it's centered at the origin. It's called the unit circle. So when people talk about our good friend, the unit circle, and in the study of trigonometry, it is our good friend, all we mean is a circle centered at the origin with a radius of 1. So I know this point is the point 0, 1. And if I needed this one, it would be negative 1, 0, and so on. I could fill them all in. You may use any radius that you want. I will always use 1, just to keep it simple. So I have chosen a radius of 1. It has generated an x value of 0 and a y value of 1. Nothing hard about that. Now I need to know the sine of that angle. Well, what did you memorize? You memorized opposite over hypotenuse, but what else did you memorize? What else was on that sheet? Tell me, I didn't have to put it on the sheet. Oh no, I put it on the sheet. What else is sine? Y over R. Sine is Y over R. Now, before you start freaking out, good job memorizing, by the way. Before you start freaking out, I want you to look over here at this one. if this regular problem, triangle, you would tell me the sine is opposite over hypotenuse, whoops, which would be √3/2, right? You would say that in this problem. Now, in terms of letters, if I had to give letters to these three sides, would it make sense to call this the x side? Isn't this the x-axis? Yeah. And then this would be the vertical, would be the y side. And that is the hypotenuse, but it also can be thought of as the radius. So when you memorized opposite over hypotenuse, that corresponds exactly with y over r. Sine is y over r. So what is the sine of 90 degrees? It's the y coordinate over the radius, 1 over 1. The sine of 90 is just 1. All right, let's try another one. Sohcahtoa, kids, awesome. I love it. But it is very restricted. You have to know more than Sohcahtoa, because Sohcahtoa is only going to work if you have a right triangle. You don't always have a triangle, and sometimes the triangle you have isn't right. So you've got to have other means, other things memorized. All right, let's try this one. Let's do the tangent of 3 pi over 2. All right, so here we go. What's 3 pi over 2 in terms of degrees? 270? Yep. That shouldn't take you very long. Pi is 180 divided by 2 is 90 times 3 is 270. All right, where's 270? If you drew 270, where would that be? That would be all the way to here, right? Is 270 another quadrantal angle? Yep. So I don't draw a triangle. I think about this circle. I think about this point right here. I need to identify the coordinates of that point. I need to know x and y. Well, I get to pick a radius, so I'm going to pick 1 again for my radius. So what would be the coordinates down here? 0, -1. And now I need to know the tangent. Okay, tangent. Since you don't have it memorized, let's put to practice what you know. In terms of this triangle right here, this would be the opposite side and this would be the adjacent side, agreed? What is that in terms of letters? This would be, that's the vertical, so that would be y, and this would be x. So is tangent, if tangent is opposite over adjacent, another way to think about tangent is y over x. So here we go, y over x. What about that? It's undefined. And if you remember looking at the graphs on the memorization sheet, at 270 or 3 pi over 2, there is a vertical asymptote. And the vertical asymptote means the function is undefined there. The tangent curve is full of asymptotes. All right, got it? All right, a couple more things. If you have your book, would you open it up for me? On to page 366. Do a couple more different kinds of problems using the same skills. Just so you know what's going on. So we're on page 366, and I'm looking at problem number 7, which is a right triangle. This is the right triangle that's drawn. This is problem number 7 on page 366. And the directions say, find the values of all the trigonometric functions. So what that means is, find the sine and the cosine and the tangent, and the cosecant and the secant and the cotangent. So here's the picture they drew. They gave you this information right here. And we said, all right, now find all 6. Any ideas what we might want to do to get started? There's probably one thing you want to do to get started. Yeah, Chloe? Yeah, you want to find that side that's missing, because at some point we're going to need opposite, adjacent, and hypotenuse, right? And we don't have all those yet. So we'll go ahead, and how can we find the side that's missing? We'll use the Pythagorean Theorem. It's a right triangle. Don't forget about your Pythagorean Theorem. So 64 plus, I'll call this y, I guess, plus y squared equals 121. So a squared plus b squared is c squared. So y squared equals, is that 57? So this is the square root of 57, which we're just going to leave it the square root of 57. That's what it is. And now we're going to fill in our information. Now, we have a right triangle, so we can do Sohcahtoa. This is the angle that you're referencing, though. All right, so pay attention to that. This is the angle. So this side would be the opposite side. This side would be the adjacent side, and this is, of course, the hypotenuse. So Sohcahtoa, sine root 57 over 11, which automatically means cosecant is going to be 11 over root 57, or 11 root 57 over 57 when you rationalize it. Cosine. Definition is adjacent over hypotenuse, so that'll be 8/11ths, which means the secant is 11/8. And then the tangent, opposite over adjacent, root 57 over 8, cotangent then, 8 over root 57, or 8 root 57 over 57. Is that pretty easy? Very, but it does require you, of course, to know your definitions, but yeah, that's pretty easy. Okay, let's look at the next one, which is number 10. Very, very similar. Problem number 10 says, assume that theta is an acute angle. What does an acute angle mean? Less than 90 degrees, which means it's in quadrant 1. So here's theta in quadrant 1. It's less than 90 degrees, so it's somewhere in quadrant 1. And I know that its sine is 2/3. Now, how will I put that into my picture? The sine is 2/3. So the opposite is 2. And the hypotenuse is 3. Does that make sense to everybody? So now we're right back to where we were a minute ago. Now we need to find that third side, doing the Pythagorean Theorem. So what would that be? This side right here, what would that be? Square root of 5. And then we need to find all of our functions. Let's use the same spots here. We knew the sine was 2/3, which means the cosecant was 3/2. That was given. What's my cosine? Yep, adjacent over hypotenuse, root 5 over 3. So secant is 3 over root 5, or 3 root 5 over 5. Perfect. What about my tangent? Or 2 root 5 over 5. And then my cotangent would be root 5 over 2. The reciprocal of the tangent. I think that's pretty easy. Right? Okay. Let's see, one more. We can get one more in the book. Let's do number 41. This one's a little bit tricky. Number 41. Now, what's tricky about this is it's backwards. So let's read the directions. Find the acute angle. All right, so again, acute means less than 90. So we are in quadrant 1. Here is angle theta in standard position, the acute angle theta. And all we know about it is that its sine is 1/2. Well, we kind of just did that. If the sine is 1/2, doesn't that mean that's a 1 and that's a 2? But now it's different because over there, we just needed to know all the other functions. Here, they're saying, all right, how big is theta? What is the measure of that angle? Well, can we go ahead and find the third side? What would the third side be? No, it won't be 1. It will be root 3. Pythagorean Theorem, 1 plus x squared equals 4. So x squared equals 3 and x equals root 3. Do you recognize that triangle? That's a 30, 60, 90 triangle. So which angle is theta? Is it the 30 or the 60? Obviously there's the 90. Is this the 30 or the 60? It's the 30. How do we know it's the 30? It's across from the 1. The angle across from the 1 in a 30, 60, 90 is the 30. So the answer to the question is theta is 30 degrees. Now, obviously, if I'm giving you that problem, or if they're giving you that problem in the homework, the triangle that you generate here has to be either 1, 2, root 3 or 1, 1, root 2. Because otherwise, you're not going to be able to know the angle without using your calculator. Okay? All right, tomorrow we got a couple more to do in this section. We'll finish that up and do 4 for you. So we'll see you tomorrow. Please make sure you're in uniform, seniors. Really important tomorrow to be in uniform. Also, I have turned back all of the homework. I still have somebody did all this homework and turned it in. It was late, but it still was half credit and there's a name on it. So if you did not get a homework paper back and you turned one in, please let me know. You have it. All right. Who else? I got a couple of you already. And we'll be all right. So Christina's going to retreat, and Sam, anybody else? No. Okay, backwoods. Danielle. Okay, you guys go on retreat. Tomorrow's a big day because we have a long period tomorrow. So there'll be video, you just need to watch it. I don't know if it'll be last Thursday, Friday, or Super late days.